and welcome back. In this lesson, we're going to explore circles. Circles are familiar shapes, but they have some very beautiful mathematical ideas behind them. As future elementary teachers, it is especially helpful to understand not just what a circle looks like, but what actually defines a circle. That deeper understanding helps us explain the shape in a way that makes sense to students. Let's begin with a point. We'll draw a point and we'll label it P. Now, let's imagine marking 5 points, like I did here, that are all 1 inch away from that point P. Then we draw 5 more points that are 1 inch away from P. As we keep placing more and more points that are all exactly 1 inch from that point P, what shape does this start to look like? Well, it starts to look like a circle. That is the key idea. A circle is the set of all points in a plane that are the same distance from a fixed point. The first thing to notice is we do reference all points in a plane. That just ensures that this is going to be a two-dimensional shape rather than a sphere. And all of those points need to be the same distance from a fixed point. That fixed point is called the center. In our picture, point P is the center, and every point we placed is 1 inch away from it. That common distance from our center and every point along our circle is called the radius. So in this example, our radius is 1 inch. This is such an important definition because it explains why a circle has its shape. A circle is not just round in some vague sense. It's made of all the points that stay the same distance from the center. Now, let's connect this to a tool students may already know, a compass. Why does a compass draw a circle? Because one point of the compass stays fixed at the center, while the pencil end moves around at a constant distance from that center. That constant distance is the radius. So the radius of a circle is directly related to how wide the compass is opened. If the compass opening is larger, the radius is larger and the circle gets bigger. If the compass opening is smaller, the radius is smaller and the circle gets smaller. This is a very concrete way to connect the definition of a circle to a physical tool. We can also draw a circle using a string and a pencil. Here's how. Attach one end of the string to a fixed point. So here's our string, and we're going to attach this point to a fixed point. We hold the other end with a pencil, and we need to do this so that this string, which I have as kind of bendy, is taut. It does need to be tight. We pull the string tight and we move the pencil around while keeping the string stretched. Why does this work? Because the length of the string stays constant. That means the pencil is always the same distance from the fixed point. And again, that is exactly the definition of a circle. This is such a nice teaching example because it shows that the roundness of a circle comes from equal distance from the center. As future teachers, this is a powerful moment to help students move from appearance to definition. A helpful question is to ask, what do all of the points on the circle have in common? The answer is not just that they look round. The answer is that they're all the same distance from the center. Excellent work. This gives us a strong conceptual definition of a circle. In the next video, we'll measure circles and discover why the ratio of a circumference to a diameter is always connected to pi.